Good afternoon, everyone. So we are going to continue with session 2 of the Introduction to Geospatial Python. Today, we are going to cover ArcGIS and one of the tools they put out called the ArcGIS API for Python, and more specifically, something that they have branded the spatially enabled data frame. So we're going to delve into this pretty heavily in this workshop today for the next hour and a half. All right, so real quickly, this is session 2, but not all of you are on session 1. Just a quick recap. So the IGIS team, the group of us who are on here are part of the Informatics and GIS statewide program, which is part of UCANR. And UCANR is part of the land-grant university system, and we are basically a college without a campus. We have offices in every county except for Alpine County with academics and staff in them. We have 9 research extension centers, and we have affiliates at, I believe, almost all the other UC campuses. So we are widespread, and we basically extend the UC's research out to the general public of California. So who am I? Who is the IGIS team? We are a group of researchers who work out of different offices in the state. I'll show you a map of that in a second. The principal people are Maggie Kelly, who's the director, Andy Lyons, who's on this call, Sean Hogan, myself, Shane Fire, Robert Johnson, Priyanka Vyas, and Genoa Stars. I just want to point out that we provide GIS drone services. We provide workshops like this. And we do GIS services or work. We provide GIS services where we create web applications, do data analysis, and many other things. And also something really of importance that we find is we also have office hours, which are available to everyone in the university, also the general public. They can sign up for a half-hour block on Mondays and Tuesdays and tell us what you're trying to do GIS-wise, and we will get the appropriate people on there to help you do your work. So we are available, and we are IGIS. So where are we? Just as a quick note, this is an example of, we've tried to geo-reference us. What you'll see is we have 6 people at UC Berkeley. That would be the director, Maggie Kelly, Andy Lyons, Priyanka, Genoa, and then 2 grad student and undergrad who work with us. There's myself, who's up at one of the research extension centers up in Mendocino County. Then there's Sean Hogan, who's at UC Davis, but actually at the UCANR building, which is in Davis, California. And then Robert Johnson, who's at the Kearney Ag Center in the Southern Central Valley. So what are we going to discuss today? So today we are going to really dig into notebooks. I call it here Jupyter notebooks, and I'll explain the differences with that. But we're going to be delving into notebooks. We are going to use the ArcGIS API for Python. This is a proprietary framework put out by ArcGIS for working with their softwares and their cloud platform to transfer data back and forth, as well as to do spatial data science using their platform and other data sets also. I'm going to give you a quick overview of the data we're going to use in this workshop, and then we're going to delve into spatially enabled data frames, importing data, analyzing data, visualizing it, and exporting the data. So we're going to go through the whole workflow today, and hopefully you will learn a lot in today's workshop. So Jupyter Notebooks, I hit on this a little bit last week. Jupyter Notebooks are an interactive environment for doing Python programming. It was originally developed at UC Berkeley. The name itself comes from 3 different programming languages that you can use inside of a Jupyter Notebook. There are more now, but originally it was Julia, Python, and R, and that is how they derived the name Jupyter. It's an interactive coding environment. There's visualization support. You can graph and everything right inside of the integrated development environment. You can include documentation in markdown language. It helps with reproducibility. You can share it widely with many different people. And all your collaborators, they can run the same code and reproduce what you've done. And it's widely used around the data science community. In fact, it's so widely used that Esri has incorporated it, or the makers of ArcGIS have incorporated it in Jupyter Notebooks into different levels of their software. If you have ArcGIS Pro installed on your computer, You have Jupyter notebooks. You also have Jupyter Labs. You have, but then also inside of ArcGIS Pro, you have notebooks that are integrated into ArcGIS Pro. Then they have ArcGIS Online, and they have ArcGIS notebooks and ArcGIS Online that are fully featured. They have a lot of libraries already pre-built in. And if you have an ArcGIS Online account with them, there are different levels of notebooks with GPU support and other support. The ArcGIS notebooks are what we are going to use today. And I want to point out that earlier this morning, you would have received an email from Robert Johnson. And that email from Robert Johnson has an ArcGIS Online account created for you with a password for this training. That guarantees that you have the proper user role assigned to the account. So if you try to use your own, you may not have a notebook role assigned to you, and that requires an administrator to do that. So we created accounts for everyone so we don't have to deal with that. I would recommend, if you can, if you already haven't, sign into that account, make sure it's up and running. So inside that Python environment, as well as in the ArcGIS, other ArcGIS Python environments, Esri installs something called the ArcGIS API for Python. This is a modern way of working with both ArcGIS Enterprise, ArcGIS Online, and ArcGIS Pro, and the spatial data they have in them. Historically, you would have different versions of Python. You would have ArcPy. You would have all these different tools that you could use to access the data and work with the data. Esri has put a lot of effort into creating one library that can work across all the platforms, and that's what we're going to be working with today. We are not going to use ArcPy. We are going to use this instead. And I should also mention that you can install the ArcGIS API for Python in your own custom Python environment. However, there's some mapping issues when the interactive mapping widget does not always work, and getting it to work properly can be problematic. And that is actually why we're also using the ArcGIS Online version of notebooks. One thing I want to point out is, Esri mentions that you can do GIS organizations and administration, so you can actually manage ArcGIS Online with this software, with this Python API. You can manage the content on API as an administrator or your own account. But really what we're going to be doing today is going to be the spatial analysis and data science end of the ArcGIS API. And the spatial analysis part is really great for data wrangling and engineering, working with spatial data as pandas data frames, which we're really going to hit on today, spatial analysis, mapping and visualization, and machine learning and deep learning. But like I said, we are really going to be concentrating on spatial data as pandas data frames. And if you want to know more about it, look into, go to this link at https://developers.arcgis.com, Python latest, or do a search for ArcGIS API for Python. They have fairly good documentation on the API and all the different functions and modules that it provides. So for this exercise today, we're going to use 3 main data sets. The email I sent out yesterday had links to we think, 2 of these. There's an Excel spreadsheet that contains all of the UCANR office locations in California. And in there, what you have is you have the location name, you have city, street, address, city, state, zip for all the UCANR offices around California. We also included a shapefile of California counties. And then we're going to use ArcGIS Online, and we're going to pull in another data set, a hosted feature layer, which is going to be the locations of all UCANR academics and community education specialists around the state. So these are the main data sets we're going to use today. What are the learning objectives for today? Hopefully by the end of this hour and a half, you'll be able to import and visualize spatial data in an Esri Python environment. You'll know how to check projections and transform the data to match. You'll be able to combine spatial data sets to perform some sort of analysis, be able to clip and buffer spatial data, and to be able to write a function to automate a chain of simple spatial data operations. And the one thing I didn't add on here is you'll also learn how to take the results and export them out as either a shapefile, a CSV file, into a local file geodatabase, or to push it up to ArcGIS Online. So hopefully you'll get that before we get done today, all those learning objectives. So with that, let's start coding. Let's get into this a little bit. So the first thing you're going to notice is log into ArcGIS Online. Please give that a try. And please, in the chat window, just put if you were successfully able to get into ArcGIS Online.
Yeah, let's give them a minute. And if anybody has any questions about the first part, now would be a great time while we're getting started here.
Absolutely. Prakash, are you able to get in? Yes, good. Thank you, Prakash. Jeremy?
Much better off building something really simple that works well, and easy to post production, because that way they actually bring financial value.
Thank you. Jeremy, were you able to get into ArcGIS Online? And Alatu Basum, are you able to get in? Jeremy, yes.
Yes, I'm able to get in.
Okay, perfect, perfect. And then there's another link in that email.
As what you are seeing now, right now. I'm not seeing.
You're seeing what I'm seeing right now? Okay, that's fine. That's fine. Okay. But if you look at the top, do you see this notebook tab as an option?
Yes.
That'll tell me that your account's set up right.
Beautiful. We'll send you a link as soon as everybody's in.
And I was just going to tell you all the email that I sent yesterday where I had the link to download those 2 files. There's another link in there that takes you to the page I'm on right now. And I will also add that into the chat window. So if you click on that link, it'll take you to the workbook for today. And then once you're there, click on the link where it says Open Notebook. So once you open the notebook, if you're familiar with Jupyter Notebooks, there's going to be a few things that are slightly different. This is a cloud-based system. So the first thing we're going to want to do so we can use the data I sent yesterday in download form is you're going to want to actually move them up to the files, direct the file system on this notebook. You're going to click on the Files button up above. Then you're going to click on, when that opens up on the right, on the left, you'll see Files. You'll see a Home directory. Click on the Home directory. And then what we're going to do is we're going to add the data that you downloaded from my email yesterday. So choose the link at the bottom, choose File to upload. I'm going to go to my download folder. And if I choose ANR locations, addresses, update 12/2024, hit open, it'll upload that file. And now I see it in my home directory on ArcGIS Online. Thank you, Janelle. And then we're also going to upload the county shapefile, the California county shapefile that you hopefully downloaded yesterday. So I'm going to say choose file. And I'm going to choose that file as well, calcounties.zip. And this is a zip file that contains the shape file of the counties of California. For those who may not know, shape files is not just one file. It's made up of a minimum 4 files or more. So you want to make sure you have all those files. So you create a zip file, and that's what you have in calcounties.zip. Okay. So.
Ken,
yes, sir.
Remind just to show me how to access, how to upload that file from your local machine.
Yes, sir. So if you click on Files up above here, Prakash.
Okay, just a moment. So file, okay.
And then you go down to the very bottom left where it says Choose File to upload.
You do have to click the Home link first.
Yeah, Home, and inside Home.
So inside of Home,
I can see new folder.
And then go further below that, go all the way to the bottom of that pane. And you will see,
I can see Home and samples data.
You don't see Home?
Yeah, I can see Home. I can also
then click on.
Okay, I click on
okay,
Home.
and then Click on home, and then when you go to home, nothing's there, right?
Yeah, nothing is there. Just the new folder. Yeah.
Okay. Don't hit new folder. Go way to the bottom of that pane.
Ah, okay.
You will see.
All right.
There you go. There you go.
Yeah, yeah. Okay, thank you.
No problem. Yeah, and then upload the zip file of the California counties, and then the Excel file as well.
Okay, right.
And these you should have been able to access from Shane's email yesterday, the day before
Yeah,
yesterday.
yeah, no, I have that file.
Yes.
Perfect.
Okay. Perfect. Thank you, Prakash. Thank you, Janelle.
Thank you. Thank you.
Okay, so then I'm going to start up here and start talking more about the programming environment. So in a Jupyter Notebook, everything is in cells. You write code in cells, you write text that you want to document what's going on in cells. And the difference really is the type of cell. So here we have a markdown cell, which is going to be text. The one below it is a code cell. You can see that up above. One says markdown. You click on the gray cell and it changes to code. Code is the one that we are going to actively work with today. It's what runs it's what runs the functions, runs everything we're trying to do. The other ones are for information and guidance. So the first thing we're going to do is we need to upload a bunch of packages that we are going to use throughout this training. Right here, you can see that we're actually uploading 3 packages or loading 3 packages. The first one is NumPy, which is a numeric array package that allows you to do advanced mathematics on arrays of items, arrays of objects. And then we're going to load pandas, which is really for wrangling data frames. It's for like basically showing NumPy array data in a format that we can understand. It puts it in a tabular format, very similar to a database or a spreadsheet. And there's a lot of functionality that we're going to delve into as we progress. And then we also load in GIS from ArcGIS. This is the ArcGIS API for Python. We are loading that in, and we are going to bring in the GIS component of that. The other 2 lines of code here are just to keep this clean. I've disabled warnings. If I didn't have that, you'd have red warnings coming up as we run the code, and that might be alarming. Basically, warnings are not a bad thing. They just tell you if things are going to be depreciating in the future or the functions might change, things like that. But they're red text, and it sometimes worries people. They're not errors, it's warnings. So we're fine doing that. The next step of this is we're going to log in. And so if you click on this very last, the next cell here, actually, sorry, click on the import cell and then hit the run button up above. The thing that looks like a play button on a VCR or a DVD player. Run that. You will notice a cursor, asterisk shows up in the square bracket when it's running, and then it gives you a number. So this was the first cell or code cell that I've run. Now we've loaded these packages in. Now if we come down here, we're going to officially sign into ArcGIS Online to use the system for the rest of this workshop. So once again, click on the one that's GIS. You can see we're telling it to log into arcgis.com. If you had ArcGIS Enterprise running internally in your system, in your organization, you could use that instead. This is my username. You'll want to put in the username you were given by Robert this morning. And when you run this cell, it's going to ask you for your password. And it will keep that password encrypted, so you cannot see it. No one else will see it while you type it in. And you hit enter or the play button above, it'll run that code for you. But the one thing you're going to notice is it doesn't advance you to the next cell like it does the other ones. So it's now done it. It's been run. So now I want you to click on the one below it. Our next step here is we're going to start working with and creating spatially enabled data frames. The first thing we're going to do though is we are going to import. We're going to be importing different types of data like the shapefile, the Excel spreadsheet, and so forth. And we're going to walk you through those steps. This next step here though just kind of gives you a hint of some things that you might use to figure out more of what different functions do and how they work. There are 2 different ways to get help with functions that you may load in, such as pandas. Here is PD for pandas. You can actually say help and then wrap the command inside of parentheses, or you can just type the command that you're interested in, followed by a question mark. If you run that, what you're going to see is it'll actually give you output of what a pandas data frame is. It gives you a brief description and tells you how they're used and gives you even an example of a pandas data frame. Just about every function and module and package inside of Python has this functionality, as long as someone has created the documentation to go with it inside that function. So give that a try. It is very helpful to know about that as you continue and build out your Python programming.
And can everybody confirm that they've been able to run the first few cells? How's everybody
you,
tested
Juno.
out the help command? How are
Yes.
things going? Yeah,
Yes, yes.
perfect. We don't want to leave anyone
Okay,
behind.
perfect.
We know it's a small group today, so please do speak up if you get stuck.
Yes, please do.
Or
Please do.
post in the
I'm
chat.
not
Yeah.
able to run after putting my password. I've not been able to run the second cell. It's so when I put it in, it said cell not executed due to pending input.
So if you run the second cell and it comes up with the place to enter your password, it's not taking your password?
I've put in my password and it's not taking it in. Yeah.
Mm.
Did you change this?
No.
Oh, change that. That's me. You've got to use the username you were given in the email today.
Yes, I did that. I changed it. I
But
changed from
Okay.
your name to mine, and I put in the password that was sent to me by email, and it's not coming up.
I mean, it worked for me. I used the password sent by Robert, in the email, and it worked.
And it should have worked to get you in this far.
Okay.
Priyanka and Genoa, the step that you highlighted in the email this morning, or in the text, the chat a little bit ago, would that work here
Probably. So
if we had to?
if yeah, I pasted it in the chat. If instead of running the code that Shane put, Shane, can you show them how to comment out that line and paste what I just put in the chat there?
Yes. Yes, I'll do it right now. So what you can do, if you can copy what Genoa just put in the chat menu, in the chat screen, and then go up to cell 2, if you put a hash sign or a pound sign before GIS, and then go to the end of that line and hit enter, what that does is it comments out that line so it will not be run. And then I'm pasting in the code from the chat window.
Okay.
Invalid character.
You may have to you may have to manually enter
Yeah,
quotes because it probably formats them weird.
yeah. So you're gonna want to change the quotes, either single or double quotes, and then rerun it, and you should then log you in.
Health of the vegetation, how much water.
Please let me know if that doesn't work.
Okay.
Are you in?
I'm doing that now. Yeah.
Okay, okay. And Priyanka and Genoa, thank you for having that handy.
Yeah, sure. It's just that with that option, when I go to the files and try to, I just don't see that option to upload the data. I mean, I do see the option to add content, but like once you have it locally on your device, it doesn't give. So should it be giving you option to upload data from your device?
If you click the files button, Priyanka.
Yeah, I click the files and then on the left hand side, there is a window that opens and there is an option to add content, but it just gives you like all ArcGIS Online content, like my content, Living Atlas, ArcGIS Online. It doesn't give you
Under
anything.
files?
Yeah.
Ooh, are you under sample data or are you under home?
Under home, just I logged in with the code that yeah, home.
And you don't see choose file to upload?
I do so files, and then there is on the top there is an add button.
No, the add button is a
No, no.
misleading thing. You have to go all the
Yeah,
way
it's
down to
totally
choose file to
misleading.
upload. It's a trap.
Yes,
Um,
it is. Am I clear to progress?
Yes, you are.
Okay. So if I go down now below the red box, if I click on the cell that starts with path, what we're gonna do now is we're gonna load that Excel file from the ArcGIS home. And to see what that path looks like, if you select the cell below the red box and then hit the plus next to the Excel file inside of the files pane on the left, it'll actually add a cell below that tells you the path, and they give it the name dataset. If you were to copy that out and just, actually, I won't even do that. If you select that cell that has a new path in it, and over on the right-hand side, you'll see an arrow. Click the up arrow, and it'll move it above that cell. And we're going to rename dataset to be Excel path. Now it says XLS_path, and it gives the path to that Excel spreadsheet. And so that we use that in our code in the next cell, I want you to comment out by using a £, the fourth line of that cell. That way we use the one that we're defining above. So in that new cell that says XLS path and gives the path name of that Excel file, if you run that by hitting enter or hitting the play button, it now loads that variable XLS path into memory, and now you can run the cell below. And that is going to go in and it's going to actually create a data frame of the Excel spreadsheet. And you can see it has location, address, city, state, and zip. But one thing you'll notice is each one of those headings for the columns have a colon at the end of them. That's going to cause problems later because some functions can't have a colon in the column name. So the next line is actually going to take and rename those column names. And this is a common thing you have to do with data frames. You have to rename columns and do different things. So I made sure I didn't fix that in the Excel spreadsheet before we brought it in. So if you go to the next cell, you will see we are saying UCANR locations, which is the data frame. We're then saying rename, and then we're renaming columns, and then we list each one of the columns. In this case, column location that has a colon in it, and we're going to rename it location without the colon. And we do that for each one of those. And you'll notice they're within curly brackets. And if we run this, what it's going to do, it's going to basically replace this data frame with a new one, but it's going to have the column names fixed. And now we can work with these column names and not have issues going forward. But one thing you'll notice is this is just a data frame. There's no spatial information in it yet. The next step that we're going to run is we're going to take that data frame and we are going to convert it into a spatial enabled data frame. And we're going to use the ArcGIS, ArcGIS Online to actually geocode those addresses and add a shape field to the data set so we can do other information. One thing to note though, is the ArcGIS API for Python cannot handle multiple fields to make up an address. So here our address is, we have address and we have another column for city, another column for state, another column for zip. In order to create that into a spatial enabled data frame, we need an address, like a full address column that combines all four of those things together. So we're going to do a little wrangling of the address. And here we are going to take each row. This is a custom function. For each row, we are going to combine together in this format. So it's going to be address, city, comma, state, zip code. And we are going to use, in here we call it row. So row.address, row.city, row.state, and row.zip. So these are just the column names inside that spatially enabled in that data frame. So we're going to run this. First off, we're going to make sure there's no blank values. If there are NaN values or NaN value is no, what is it? Null. I can't remember exactly what
Not
it
a
is
number.
for null. And what was that? Oh, not a number. Thank you, Prakash. So not a number. You're going to say if it sees that, it's just going to make an empty string. And this piece here where it says in place means we don't have to assign it to a variable. It just does it in place, and you're good to go and move forward. Now here, we're going to go in and we are going to apply the function create address at the row level. By doing that, when we run this, what you're going to see now is we have a new field, a new column. That's a concatenation of address, city, state, and zip. If zip is blank, like lines 3 and 4, it's just not added. There's there's no error there. It knows how to deal with it because of the fill not a number piece here. Question I have for you right now is this a spatially enabled data frame? Anyone chime in? Is that spatially enabled yet?
No, it doesn't have any long lab.
Exactly. There's no spatial information. You're exactly right, Prakash.
Mhm.
So the next step we're going to do is we're going to take that data frame, and when we load the ArcGIS API for Python, it adds additional functionality to a Pandas data frame. And one of the things it adds is a new namespace called spatial. And spatial has different functions that you can run. So if we do spatial.from data frame and we specify an address column, such as full address, and we run this command, it will create a spatially enabled data frame. One caveat, when you run that, it does consume credits from ArcGIS Online. The only thing I want to tell you is be careful on the sheer number of things that you geocode. The cost isn't that expensive in terms of code, but if you do a lot of addresses, it does add up. Also, I want to point out is you have a lot of columns here now. You can see the original ones. We have location, address, city, state, zip, and full address. And all the rest of these are from the geocoding operation from ArcGIS Online. So one of the first things we're going to do is we are going to get rid of a bunch of columns we don't need. Also notice how city X, you have a column here called city X. If you look elsewhere, you'll have a column called city Y.
Mhm.
So what it does is it's found duplicate columns in the geocoding task and the original data frame. It can't have two columns of the same name. So they add a suffix of -X for the initial data set, or for the first data set that you're applying the geoprocessing to, and then it adds an _Y to the other. And that's noted in the note below. So the first thing we're going to do is we are going to clean up the columns. We're going to bring it back to just what we need. And if you were to look at all the columns that you have in this data set, you're going to see one called shape. And shape has latitude and longitude. Prakash, like you were saying, wasn't there yet. So this is now a spatially enabled data frame. So we are going to go in and we are just going to bring back these columns: location, address, city, state, zip, and full address, and shape. By running this command and wrapping those column names inside of square brackets, it'll subset your columns down and only bring those back. And then we're going to reapply a rename function like I showed you earlier. And we are going to change city X back to city. And we're going to do that in place, which I described above. By running that, what we're going to notice now, we're back to a smaller data set in terms of columns: location, address, city again, state, zip, full address, and shape. And this is a spatially enabled data frame. One thing you may wonder, I know last week we talked about projections and how important projections are. There's another piece to the spatial name, the namespace as a function there called SR, which allows us to report out the spatial reference system of this spatially enabled data frame. And what you'll notice here is it's 4326. Question I have is, what does that mean? If you were to click on this link, it'll take you out and you can see what 4326 is. Long story short, it's a geographic coordinate system, so latitude and longitude. And the importance of projections are you want all of your data to be in the same projection so that you guarantee you don't have issues that can be derived from using the wrong projections or different projections when you do analysis. So a good rule of thumb is when you bring in new data sets, check their projection, make sure they're the right projection and that all your projections match. So the next piece of this that was bringing in an Excel spreadsheet and turning it into a spatial-enabled data frame. The next piece of this is we are actually going to pull data directly from ArcGIS Online. This data set is going to be a data set of UCANR, so University of California Ag and Natural Resources Division. This is going to be their academic people who are academics or community education specialists. This is a data set that IGIS curates and keeps up to date. We're going to bring this in by its item ID. I'll have you note that every item in ArcGIS Online has an ID, such as this notebook that we loaded originally. The number after ID equals is the ID. We can go in and we can say, get this item. Whoa, hold on, what just happened? 1 second. We can go down here and we can say GIS content, get, and then put in the ID number. And that ID number, you can see it here in the URL at the top of that cell. If I do that, it searches, it finds it, it brings it back, and this specific item only has one thing in it. So we're saying bring back the first item. Keep in mind, we mentioned last week that Python is zero-based. So it means that counting starts at 0, not 1. So the first item is 0. So in this case, we're saying bring back the first. And then we say query it and bring it back as a spatial-enabled data frame. If we run this, what we're going to see, it'll take a couple seconds. It brings back a spatial-enabled data set. I added another piece of code here. I'm doing a print statement, and I'm telling it to give me the shape of that data frame. So what that tells us is that that data frame has 751 rows and there are 16 columns. So it gives you a really quick feel for what's going on with your data. And in this data set, you can see their academic title, people's names, where they're located, specific location, if there's one, what they work in, what their working title is, if they're in more than one county, and what program area they put their time in. So it's information about these people and where they work in California. I already answered the bonus question, which was what's the how many rows and columns. And once again, that's derived by the shape function, and it brings your data out as a tuple. So that's how you use and bring data in from ArcGIS Online. You can do that with posted feature layers. You can even do something similar with rasters. We're not going to get into that today, but data that's stored in ArcGIS Online, you can load in that way. The next thing I'm going to show you is how to work with shapefiles.
Oh, can I just mention that? I just want to mention
please.
that one of the real strengths of using this sort of ArcGIS Online notebook is the ability to access data so easily from ArcGIS Online. So if you work for an organization like ANR or Berkeley or a university that has a lot of data that they host in ArcGIS Online, this is a really great way to be able to access data that people are kind of updating and keeping there really easily and efficiently without like emailing it back and forth. So this has a lot of benefits, but also, you know, its share of drawbacks at the same time.
Yes, that's a really good point to know. And not only is it like within your organization, there's an entire repository on ArcGIS Online and something Esri calls the Living Atlas, which there are data sets from all over federal, state governments, all over organizations. There's data, there's we do not live in a data poor environment right now. Let's put it that way. Prakash, you had a question.
Shane, yeah, please describe a little bit more on what types of data, can we get there and where, and exact, exact location of that, directory.
Sure. For like me, I use a lot of data from CAL FIRE. And they host a lot of their data on ArcGIS Online. And anytime you Google a data set, so say I wanted to look at fire perimeters,
Yeah,
and
that's very
with the term
important.
ArcGIS Online, it will pull up their data set in ArcGIS Online. So here's an example. I'll paste it in the chat. And just like Shane was talking about, that ID number I could then use with this command, item equals GIS content.get, and it would pull that data set right into my notebook. And as CAL FIRE updates it, the URL stays the same. So refreshing the notebook or running the command again, had they updated the data set, would pull the newest data, which is pretty cool.
Okay, so wait a moment there. So instead of that 8713 or something, could you, just use that link there and show me, demonstrate me how data from CAL FIRE you can get access to?
I can't because I'm not sharing my screen. But
no, but any
what was?
Oh,
yeah.
I pasted
What was that
another
question,
data set.
Yeah, so the question is, instead of the already available that link, would you mind putting something else there from ArcGIS Online?
Yeah, I'll do that. I'll do that right now, Prakash.
Yeah, yeah.
It's pretty cool.
Okay, so I'm going to click on just the ID part. Actually, let me do. Yeah, I'll do that.
Mm-hmm.
I'm going to go in here and I'm going to duplicate that one line of code where I brought that data set in. So I'm going to go down to right here. This is the county. No, that's the academics. I'm going to copy and paste that cell.
Just so that he doesn't
And I'm
erase
gonna
the
read
code
it.
we're all following.
Exactly. So I'm going to go down here, and if I replace this ID with the one that Genoa had put in, and now I'm just going to quickly, what was this data set called, Genoa?
It's a fire perimeter.
Okay. So now I'm going to give it a name, fire perimeter.
So you didn't copy the whole URL. You just copied that,
I just
Yeah.
copied the ID.
And if
You can do the whole URL, but I don't have it set up that way.
No,
here.
that's okay, but
It just makes it easier.
So you went to that URL and you got that ID from there, right?
Yeah, it's also the last chunk of the URL. If you look at the link, it says
okay,
ID equals. Yeah.
Okay.
Yep,
Okay.
it's right there.
Got it.
And then if I run this, what it's going to do is exactly what Genoa was just describing. It's going out, it's pulling the data. And in this case, it has 2 items in it and 8 columns.
Oh,
So he probably only pulled the subset,
yeah, so
or it was like the first layer.
Yeah, this is really cool because you don't have to download and upload again, right?
Yeah, it's really great because you can access real-time data. It's scary because you don't have control unless it's your data. So it's kind of
Genoa.
Yeah.
I just wanted to point out this layer only has 2 items in it.
Well, then it worked like a dream, didn't it?
Exactly.
So it's the higher perimeter, so it will just give you length, right?
You just want to make sure. So when you go back to the link, the window with the data set open.
Yes.
So you can preview the data that you're bringing in by clicking open in map viewer here. So Living Atlas has things like this too. So you can take a look and see like, oh yeah, this is what I want to use.
Yeah.
This is not the official CAL FIRE one. I just did a really quick Google and this is what came up. But yeah. So any data set in ArcGIS Online that's public, you can do this with.
Okay.
Yeah.
Okay. So if we just search in ArcGIS like online data available, we can get that, right?
Yeah, and I would make sure you look at the description and information to make sure it's from an appropriate resource. So this is by some guy called Mark Landscape. I would look for the one that's posted by CAL FIRE.
Okay, cool.
And often CAL FIRE will have it marked as authoritative, so you know that that's the layer they want you to use. Okay?
Yep.
Okay. So if you want, try to get the shape of either one of these really. But I'm actually gonna get rid of the example that we just did for Prakash. No offense, Prakash.
Thank you. Yeah.
So I'm gonna get the shape of this layer. Oh wait, no, we've already done that. I'm sorry, we're down further. So how do we do something similar with shapefile? In this case, we're going to use a shapefile that is we uploaded to the files directory. So it's in the home directory. It's called calcounties.zip. In this case, it's already in here. So it's ArcGIS home. Oh no, it's not. I did something different. So what you can do is if you change this and just take out the word cal shape. So now it matches exactly over here. So it's going to be ArcGIS home, Cal County zip. And what this is going to do, I actually have a function built in here that's going to extract the zip file back into the same folder. And then we can bring that in as a spatial-enabled data frame. So if I run this, what's going to happen? It's going to unzip it or not.
It's not unzipping.
Yeah, I mean, it can't open. So
Why did it not zip?
Cal County. So inside home, Cal County zip. You already have that. Right?
Oh, hold on. Making it too hard. Hit new folder.
Yeah.
It doesn't like that it doesn't like that folder doesn't exist. They're going to say new folder called cal shapefile.
But it does exist.
Apparently it thinks it does. Let's go out.
Yeah, Cal
Oh, it
County.
does exist.
There it is.
Yeah.
Oh, I don't know what the problem is. Okay, let me see if I haven't tried this. Let me see.
I mean,
Nope.
it worked for me. I was in the same folder.
I wonder if you've just uploaded it several times and it's upset with you, Shane.
Yeah, there it is. Okay, let me look here once. I'm going to, since I'm having problems, I'm just going to comment
Yeah,
this out.
just please run one by one, like line by line, then.
This is also a
let's see what
natural
that
part
does.
of the coding process.
Yeah.
It really is.
Good.
So by commenting that line out, it was trying to save it to that location, the extract path. It already has it in there and it opens fine. And I'll explain why, but it's working fine now. One thing you'll notice is this has all the data from the shapefile, county name, abbreviation, county number, and so forth. There is a shape field over here on the right, which is what we're going to want. And this would work as a spatial-enabled data frame for our analysis. Weirdly, this specific data set will not map using the mapping widget, which is part of the ArcGIS API for Python. So I'm going to have you load in the original data set from ArcGIS Online by using the next command. It's the mirror of this data set, but it's coming from ArcGIS Online instead of a shapefile. And that's just so we can map it and view it easily. Okay, so now we have spatial-enabled data frame of locations of A&R offices throughout the state. We have locations of A&R academics and communications education specialists around the state, as well as a spatial-enabled data frame of counties. The next thing we're going to do is we're just going to see what these look like on a map. So we are going to call something called the GIS map widget. We're going to tell it that we want the area to be zoomed into California, and we're giving it a variable name of map 1. Now, to get the data to show up, we're just going to say the spatial-enabled data frame, in this case, California counties, .spatial, plot, and then we're telling it to go to map 1. Then we're going to say map the UCANR academics, and we're going to plot that, add it to map 1 again. the order these things are added becomes the order they're added to the map. So in this case, counties is going to be below, is going to be added first, and then the points are going to be added on top of that. And then we're just saying load the map. This may take a couple seconds to run, but if we run this box, it'll take a couple seconds, then you will get an embedded web map, or what looks like a web map on your notebook.
Yeah, I like to think of it as when you start the map object, it's like, okay, this is the frame and the background, and then it stacks the layers bottom to top. So if you're ever having symbology
That's a really
problems,
good way
just
to put it.
remember that. Yeah.
And you can see this takes a little bit longer, so that asterisk is still churning away on top.
So just so I understand, so the California USA
Yeah.
is the base map, and the CA counties and UCANR are the layers?
Yes. And the California USA is not really the base map. What it is think of it as the extent. So the map's going to draw with the extent of California USA.
Okay.
Esri's not like super flexible about its base maps, so you're going to get what Esri gives you. But it's telling it kind of where to center it and how big to make it.
Thank you.
Has anyone's map drawn yet?
Mine did.
What was that?
Did.
Yours did? Okay.
Yes.
One of the painful things about notebooks is with this cell running, it has to complete before it'll do other cells below it. Of others who are mapping, has the map piece come up yet?
Mine's come up.
Yours has come up? Okay. Of course, mine has not. So everyone bear with me just for a second. I'm going to restart and get back to this point quickly. That's also a nice thing about notebooks is you can get back to a point quickly. And I just won't run that map piece so I don't get stuck there again. Give me a second, everyone. I'll be in the exact same spot. See if the shape file runs. All right. Okay. So I'm back to where we were. I am going to skip the mapping piece so we don't get stuck. So now, ideally, picture a beautiful map with the data on it. What we're going to do now is we're going to summarize the information. So what I mean by that is by spatial information, we're going to take the point layer that shows all the academics around the state of California, and let's create a total or a summary for each county, what type of academics are there and how many of them. So what we're going to do first off is we're going to do a spatial join. So we're going to say, here are all the points, take the county layer and assign county to each one of those points. So what we're going to do here is we're going to run this thing. We're doing a spatial join. This is with the academic data set. We're going to use the spatial spatial namespace, and we're going to use the join function. The default operation from the join function is an intersect, but there are other operations you could do. And you could do the help function that we showed right in the beginning to find out how to use those other operations. But here we're just going to do an intersect. And if I run this, what you're going to find, and this is the weird thing about this one data set from Esri, is it has some geometry issues. So you're going to get these failed validation issues. but the data set's still fine. The results are still fine. It just throws some errors in the beginning. And now what you see is we have all the information from the academics data set, but then there's also this other information appended to it, the information from the county data. So we can see that you can see the individuals who are in each one of the counties, as well as more information about the counties. But this is still a point layer. What was that?
Oh, I'm sorry.
Oh, okay. Yeah, so this is still a point layer. So we're going to go in here now, and you may be wondering, like, how many columns or what columns are now in this data set? So we are going to go out and we are going to look at the spatially enabled data frame, so SDF2 that we just created. And we are going to have it list out all the column names, and we're going to print those just so we can see what's in there. And you can see there's quite a few columns now in here. Let's go now in and take that resultant data set. And I want to go in and I want to say, in each county, so in each county name, give me the counts of each one of the items in the academic title. So we're going to see CE specialists, project scientists, and so forth. We're going to get the counts of each one of those in a given county. That's where we want to get to. So what we're going to do is we're going to run the following command. We're going to do a group by, and we're saying group by county name. We're going to say group by county name. We're going to also group by academic title. And then we're going to get the count, so the size of the academic name. And then we're going to reset the index, which basically means we're going to renumber things from 0 up instead of just getting a random, it's not really random, but a different count. It's not going to go from 0 to a number. It'll be based on the first occurrence of each one of the groups. And then we are going to sort it. We're going to sort it descending. And if I run that cell, what I then get is county name, it's sorted descending, so YOLO counties first. Then you get the academic title, CE specialist, community education specialist, academic coordinator, so forth, and the counts in each one. And now I'm going to do a pivot table because I want to get, if I tried to graph this right now, you'd have, let's say, a bar graph. You have a bar for each one of these occurrences. You'd have a bar of 120, bar chart with 129 bars on it. And it would just show the counts of each one of these things in each county. I'm not going to do that. Instead, what I'm going to do is create a pivot table. So I'm going to have a table that's going to have in the row column is going to be county name. Across the column names is going to be the academic title. And inside there, in each one of the cells, is going to be the counts of each one. And I'll show you what that looks like here in a second. If any values are empty, so let's say you don't have a certain type of academic in that county, we're going to fill it in with a 0. That's what this code does. If I run this, what you get is a simple table or data frame, county name, each one of the different types, and the counts in each county. So let's graph this and see what this looks like. We're going to use matplotlib to do that, which is a library that comes with Python. And we're going to create a stacked bar chart. And it's going to be horizontal stacks versus vertical. If I run this, I'll end up with a chart that looks like this. And it's sorted right now by name, just like our data frame up above. But it's not really that easy to read to see who's got the most and who has the least. You can tell YOLO has the most, but you can't tell who has the least. So what we're going to do is we're going to solve that. We're going to sort the data by the total and then graph that. But what you'll notice is when you look at this data frame, we don't have a total number of academics. So we're going to calculate that by creating a custom function. Up above, we did a lambda function where we created the full address. We're going to do the same thing here, but instead of concatenating everything together, we're going to do math and we're going to add each column together. So here we're going to say, go row by row and add each one of those values, each one of those columns, academic administrators and so forth. and we are going to store it in a new column called sum. We are then going to sort it by sum. And then just so we don't end up with that in our chart, we're going to delete the sum field after we sort it and then graph it. So here's the table. You can see now it's sorted by the total column. So now it's not alphabetical anymore. Now it's by the total number of each, the total number of academics. And if we plot that, now it's ordered from least to most. Del Norte has the fewest, and actually the real fewest is Alpine, because we have no one in Alpine County. And the most is Yolo County. And that is where ANR's home office is, and that's where most of the people are. One thing we mentioned earlier is think about projection. One thing we haven't done is done something as simple as check to see if our projections are the same. You can test that by just looking at the data frame, the spatial namespace, and spatial reference. And you can compare two different data frames as simply as checking if they're equal to each other. If I run this in fact, they are equal. So it's good that we're doing the analysis on these data. If they weren't equal, you could actually go in and you could change the projection of a data frame as simply as the data frame name. So we could use UC Academic CES. You would then say spatial.project and then just put in the CRS code. So we could, if we use 4236, it would reproject it to geographic data. We're not going to do that because that would cause errors in the preceding steps that were the next steps that we do. So far we've done a lot of.
Oh, just a quick note.
Go ahead.
A lot of ArcGIS online products, almost all of them will be in Web Mercator, which looks really great with like the base map and how Esri plots things, but it's not great for like spatial analysis or if you're doing area or distance. So just keep that in mind.
Thank you, Juno. That's a really good point.
So which will be better,
So the next,
the analysis like area and length?
It depends on where you're doing your work.
Like in California, like, in Merced or, in other county?
What do you think, Shane? UTM or
yeah, it depends on the scale also. If it's statewide scale, probably Teal Albers. But if you're doing something, let's say Merced, Prakash, let's say UC Merced, it's such a small area, you'd be best served by probably using UTM, Universal Transmercator.
Okay, but what if
because it does a really good job on area and length.
Okay, but what if, if I use all the pistachio growing areas or the walnut growing areas or something like that? Not in Merced, but, all over California.
I would use NAD 3310. Or is it 3110?
What is that?
California Teal Albers.
Yes.
Okay.
Yeah, it's a projection very specific to California. And the only thing I would add to that, Prakash, is use the most recent datum. You don't want to use NAD 27. You don't want to use NAD 83. I would use WGS 84.
Okay, and does that make difference for Northern and Southern California?
No, that projection is set up where it's valid throughout the state of California.
Okay. Thank you.
So the next thing I want to talk about is one strength of Python is the ability to create functions and do reproducibility. So what I've done is I've taken some of the steps we've done before up in the preceding cells and even added a new one just to show how it works and created a custom function. What this function does here, and first we define a function by saying def or define. We give it a name. In my case, it's sample function. Then you tell it what parameters it's going to need. So what information does that function need to run? In this case, it needs two data frames, so counties, academics. Then it takes two other variables in this case. This is a county name as a string, and then a buffer distance. So what this function does is it subsets the counties by just the county name you put in. So in my example below, I'm bringing in, I want Mendocino County. So it's going to subset counties down to Mendocino County and save it as a new data frame called county. Then I'm going to go and this function is going to buffer that county by the buffer distance. So I say county.shape, this is the namespace of shape, has a function in there called geometry, or not even a function, another namespace called geometry, and a function called buffer. So what I'm going to do is I'm going to buffer that shape by a distance of whatever I specify, in this case, 1,000 meters. It's going to save that in the county data frame. So now we have two different shape files, two different shape fields or geometry fields. That'll still work, but ideally you only have one for what you're trying to work with. So we're going to drop the first shape field and only keep the one that has the buffer of 1,000 meters. I also want to point out buffers can be negative as well. They don't just have to be positive. So I drop the shape field. But then I'm going to do another spatial join, just like we did above where we added county. But for now, what I'm going to do is I'm going to have it do a spatial join. And what it's going to do, because I'm just joining it on Mendocino County, the end result is only going to be those academics that are in Mendocino County. I'm then going to do the same pivot table on the resultant data set, and I'm going to return out 3 items that I just calculated. The new data frame that contains Mendocino County, the new data set that is the spatial-enabled data frame of just the academics in Mendocino County, and then the resulting table of the pivot table. They're going to be brought back from the function when I run it. So I've defined it. I've now loaded it in, so that function is known by the notebook. And now I myself am going to say, I want Mendocino County, 1,000 meters, and I'm going to bring back the select county, which is the first item in this return statement. The second one is the academics. The third one is the table, and you can assign those variables in that order, and it'll save each one of those things as those values. So if I run this now, it'll take a couple seconds. And feel free to play with yours on your end, change the county, change the distance, and just see what happens. Now, if I look at select academics, I can see I have 5 rows in select academics. If I look at the pivot table, oh wait, no, I have a head on that. That's why there's only 5 rows. If I look at that, there's 11 people in Mendocino County that are either academics or community education specialists. If I look at the pivot table where it summarizes those up, I will see that I have 5 advisors, 2 specialists, and 4 community education specialists for a total of 11 people. And you can try that with any county you want. The nice thing about this is you don't have to write all those individual cells. You could write a loop where you loop through each county, and you could create anything you want by using that, any outputs you want by using that function, knowing that you're going to get those 3 items back in return. But give that a try on your own. Let's see what happens. I'm really reticent to run this next cell. We will do that in a second after I go over exporting data. And the final cell I'll run would be this GIS map. I just don't want to lock things up before we finish. We are in the final stretch right now, and I just want to talk about taking the data that we produce and exporting it, whether it be a table as a CSV file or a spatial-enabled data frame table as an Excel spreadsheet. We'll talk about that. Actually, I don't think I'll even show that, but you can see it here. But then I'll show how to save data as a file to a file geodatabase or a shapefile by doing 2 feature class. And then I'll also show you how to save a feature layer up to ArcGIS Online using 2 feature layers. So we're going to do those 2 things. So the first step I want to walk you through is actually creating a shapefile. So when we use this tool here, it's going to actually, we use this function, it's going to create a shapefile. It's going to zip it up. It's going to zip it up and store it in that location in our home folder. So if I run this, it's going to take the select county spatial data set. It's going to save it as a feature class. It's going to put it in the ArcGIS home folder. I do not have it in the counties. Do I have it in the counties? No. On mine, I did, so I'm gonna take the counties off. I'm gonna save it as, oh, actually take it back. It's gonna actually save it in a new folder called counties, and it's gonna be called select county shape. The next step is it's gonna take that location, select counties. It's gonna take all the files that have the name select county and create a zip file out of that. So once again, there's a custom function, and then it's going to do the work and pass out a zip file that we're asking for. If I run that, it's going to run for just a second. If I re-click on home, there's now a new directory there called counties, and it has the select county as shapes. And if I go back to home, we have a select county zip file. And if you were to download that, you could open it in your own ArcGIS Pro on your desktop or wherever you want. You could also substitute a path as well as a feature class to a file geodatabase on your computer if you were running this on your computer instead of on ArcGIS Online, and it would save to a file geodatabase as well. Similarly, if you ran to Excel or to CSV, you just put the file name in and it would actually save it out to those files. It's really quite simple to do. The other thing I want to show you, and this is going to cause an error, and I specifically want it to cause an error. I'm going to take the select academics piece I wrote. I'm going to try to save it to ArcGIS Online. I'm going to change the name so I don't have anything conflicting. And if I run this, weirdly, it'll explain why, but it's going to give us an error. Even though I download these data from, actually not this one, a different data set, I downloaded from ArcGIS directly, it's still through the same error. It's telling me that the column names are greater than 10 characters, therefore it cannot push it up to ArcGIS Online. So I wrote a custom function that shortens the names to 10 characters or less to meet the requirement that they're saying. And by building that function and running that function on the data set and saving it back out to select academics, it now has character names that are shortened. And if I run this, it will successfully push that up to ArcGIS Online. So essentially now, hopefully you have seen, this is the last step of the workshop itself. Hopefully now you have seen how you can work with ArcGIS Online, how you can bring data in as a spatial-enabled data frame, whether it's an Excel spreadsheet, a shapefile, data directly from ArcGIS Online, how to perform spatial analysis, how to graph the results, even how to map the results, and I'll try to run that in a second, how to export the data as a shapefile, how to export, and also how to export the data to a hosted feature layer. And here you can see this layer is actually on ArcGIS Online right now. I just published it up. If I click on that link that it showed, it'll actually open up. And if I go to, when it resolves, if I go to visualization, I will see the points and they'll only be in Mendocino County. So it'll zoom in, and then here are those points in Mendocino County. There'll be some in Ukiah. It's going very slow. And then there's some down at Hopland Research Extension Center in Mendocino County. So back to the one cell I did not run because I was leery of killing the project before I finished. So if I go back up here, let's see if map 2 runs. If it runs, what we should see is all the counties of California. Then you'll see another one, a reproduction of Mendocino County, as well as the points on Mendocino County. For me, Mendocino County. And then as you zoom in, you can see that Mendocino County has been buffered 1,000 meters. So let's let that run and hopefully it does show up. Any questions? We have a few minutes, we have less than 10 minutes left. You guys have any questions for me or for us?
I have one question, and I mean, it may not be relevant now. If you could answer it at any point, it'd be great.
Yeah.
I had a GeoJSON with nested fields, right? I always find that like when I try to import that into a data frame, like if a field has additional nested fields in it, it comes through as just values that are nested, and I struggle to be able to dynamically flatten all of those things into one flat data frame. Do you have like any recommendations, or do you ever come across that?
I have not. I'm trying to think of the best way to handle that. I'm going to punt a little bit on that one to Genoa. Genoa, have you had to deal with GeoJSON and nested data?
I'm gonna be real with you. When I use GeoJSONs, I usually use open source geospatial processing. I don't usually go to Esri as my first choice. Not that it can't handle it. Sometimes I usually would do this in ArcGIS Pro if I'm dealing with like really large, complicated data sets, because I find that ArcGIS Online doesn't really offer users a lot of flexibility. Yeah. What are you working with, Lee?
So we have some, and it's really data that I'm importing from, I think it's called GeoServers, WFS, and trying to like create different map layers in ArcGIS, but I'm importing it with Python. But I always run into the problem where I'll import when I import it with GeoPandas, I'm sorry. When I import it with GeoPandas, it always will get the first 2 layers of nesting, and then beyond that, everything it just considers a value within those columns.
Is it a raster or a vector data set?
It's a raster data set.
Gotcha. Yes. I think you should schedule an office hours appointment.
Okay.
Yes.
All right.
That's a really
Just
good
because
idea.
we've kind of glazed over rasters because, again, ArcGIS Online and rasters are not very friendly. But we love them. We do love them. So yeah, we'd be happy to chat about that sometime. And give it a
Thank you.
Thank you, Lee. One thing I'll add is the reason I like the ArcGIS API for Python even more so than ArcGIS Pro is because, at least when it comes to working with tables, because you can push them into a Pandas data frame, and Pandas handles tables and working and doing data munging, data wrangling. It handles it much more efficiently, and it's way easier to do a lot of things and then push it back to ArcGIS Online or ArcGIS Pro. But there are still some limitations, like Genoa mentioned. She tends to go more of the open source route, which is something that we will be discussing next week. But there are pros and cons to each. I do like the tighter integration of this tool with Esri products because, it's their product. But there are some limitations. Like right now, for instance, mapping's not working. Why? I do not know. But there are some interesting things, but I do like it for working with tabular data a lot.
full
Any
disclosure.
other questions?
You can also do that in ArcGIS Pro.
Yes. Yes. What do you mean by that in ArcGIS Pro?
You can use ArcPy.
Oh, yes. Yes. But ArcPy doesn't, you can push it out to a NumPy data array and then bring it into a Pandas or read it into a Pandas, but it's a little bit clunkier.
We're really glad you guys came today.
Yes, thank you so much.
Andy just pasted the workshop evaluation in the chat. This is, again, a new workshop that Shane has worked very hard on. And so if you are happy to provide feedback, we would be delighted. If you're less happy, we would love to hear the feedback because we want to make this reusable and help.
Thank you all.